Hey everybody, welcome to Pre-calc Lesson 1.6 on piecewise functions. So let's talk about what a piecewise function is. A piecewise function is simply a function defined by different parts for different domain intervals. Different domain intervals. So that means the look of the graph is going to change depending on where you are on the x-axis. So here's a simple example of a piecewise function. A museum charges $12 per person for a guided tour with a group of less than 10 people, or a fixed $125 fee for a group of 10 or more people. Write a function relating to the number of people, n, to the cost, c. All right, so they want a function, c of n. The cost per n number of people. Well, there's two different rates here, if you will. The first one has to do if there's less than 10 people. So if there's less than 10 people, it's going to be $12 per person. Well, algebraically, that's pretty easy. That's simply just 12n, 12 times the number of people. But that only works if n is less than 10. So what do we do if n is more than 10? Well, that's simply a fixed $125 fee. So it doesn't matter how many you have, 10 or 100, it's going to be $125. So that piece of the function is simply going to be 125 when n is greater than or equal to 10. All right, well, we're not going to have a lot of word problems, to be honest with you, in this course, but we're going to have problems that kind of look like this. Given the function f of x, sketch the graph of f of x. So f of x equals 2x when x is less than or equal to 0, 0 when 0 is less than x is less than or equal to 4, or x minus 4 when x is greater than 4. So it's going to change. Where is it going to change? Well, one of the changes occurs at 0. So right here, the function itself is going to change from 2x to 0. Where else is it going to change? Well, it's going to change at 4. So right here, it's going to change from 0 to x minus 4. Now, one of the things I like to do, just to kind of illustrate this, I just want to caution you, though, these are not part of the graph. They're not asymptotes, but it's just to highlight where this changes. So at 0 is going to be one change. And at 4, it's going to be another change. All right, so let's sketch this. I'm going to color code it here. So my first piece, when x is less than or equal to 0, is simply going to be 2x. Well, if you remember, that's just a linear function. My slope is 2, my y-intercept is 0. Okay, well, I can sketch that. If my slope is 2, my y-intercept is 0. There's 0 for y-intercept, but normally what you would do next, you'd probably go up 2 over 1, up 2 over 1, and you'd start to sketch this in. But remember, this function does not exist here, and it doesn't exist here. This function only exists when x is less than or equal to 0, so it's only going to exist in this space. So instead of going up to right 1, up to right 1, and keep doing that, we're going to have to go backwards, down to left 1. Put a point there, down to left 1, down to left 1. So what I'm going to see is this. So this blue ray, if you will, represents this piece right here. And notice I did a closed circle because it's less than or equal to. Now the next one's pretty easy to work with because it's a constant function, all right? Meaning there's no x here, so it's just always 0 as long as x is between 0 and 4. Now most of you probably recognize that a less than means an open circle and a less than or equal to means a closed circle. We just have to be a little bit careful because one thing that we do not do, I don't want to see this, I don't want to see an open circle over top of a closed circle. Never do that. If the two segments have a common point, meaning they both do right here, and one of them's open and one of them's closed, you just make this a closed circle. So for this piece, between 0 and 4, it's going to look like this. Now for the last piece, again, this is linear. Okay, and what do we know? We know my slope is 1, and my y-intercept is -4. But we've got to be careful because this is not the y-axis. This is the y-axis. So your y-intercept is here, and your slope is 1. But remember, you're not going to see this piece because you're only going to see this line when x is greater than 4. So what you have to do is kind of visualize, all right, here's a y-intercept of -4. My slope is 1. So I'm going to visualize this until I get here. And because this point is in common with this function, even though you might think, oh, open circle, it's the same point. So we're just going to go from here upwards with a slope of 1. Okay, so it's going to look like this. So what we've just done is we've just sketched all 3 of these pieces, and we can see how they change at 0 and at 4. And this here is my piecewise function. Okay, well, now let's see how we would evaluate it. All right, this is the same function that's written up above. I just wanted to copy it down here so I wouldn't have to scroll. So here's how we do this algebraically. I want to evaluate f of -3. Well, how do I know whether I plug it into 2x or 0 or x minus 4? It simply depends on where this is in these intervals. It can only be in 1. So where's -3? Well, this is pretty easy. It's less than or equal to 0. So since -3 is in here, I'm using this part of the function. So that's going to be 2x, 2 times -3. That is -6. Okay, next one. I think you can probably get the hang of this. F of 2. Is 2 less than or equal to 0? No. Is 2 between 0 and 4? Yes. Which means it's just going to be that. It's a constant at 0. There's nothing to plug in. No work to show. And then the last one, f of 8. Is 8 here? Nope. Is 8 between these? No. Is 8 greater than 4? Yes. So I'm using this one. X minus 4, that's going to be 8 minus 4, and that's 4. Example 2, g of x equals 4 when x is less than or equal to -1, negative x plus 3 when -1 is less than or equal to x is less than or equal to 3, and square root x minus 3 when x is greater than 3. What we're going to do here first, we're going to do the algebraic evaluation first, and then we'll make a sketch. G of -10. So remember what we have to do. We're not going to plug it into all 3. We're not just going to pick which one we like better. It depends on where this is among these intervals. So -10, again, should be pretty obvious, is less than or equal to -1. So that's going to be 4. It's a constant function, no work to show. So next, where is 1 in these intervals? Well, 1 is not less than or equal to -1. Is 1 between -1 and 3? Yes. So I'm going to use this piece right here. Negative x plus 3. So that's going to be -1 plus 3. So obviously that's going to give me 2. And the last one, g of 9. It's not less than or equal to -1. It's not between -1 and 3. It's this one right here. It's greater than 3. So what I'm going to do is I'm going to plug a 9 into that piece. So that gives me square root. 9 minus 3 is square root 6, and we're just going to leave that. We'll assume this is calc inactive, and there's nothing to simplify in that radical. Okay, let's sketch this one. That's the same function that was up above. I just wanted to bring it down. So where is this function changing, if you will? At -1, so right here it's going to change from one part to another, and at 3, right here it's going to change from one part to another. So again, just as a visual, again, it's not part of the graph, but I know it's going to change here at -1. And again, just as a visual, I know it's going to change at 3. So this one here, pretty straightforward. It's a constant when x is less than or equal to -1. So it's going to come from the left. It's going to end at a closed circle. All right, so x equals 4. Or sorry, y equals 4, 1, 2, 3, 4. It's going to stop right here with a closed circle. All right, so the next one, and this is kind of nice because if you notice here, for this piece, basically I have, double arrow, slope of a -1 and a y-intercept of a 3. And my y-intercept, the y-axis, is actually in this interval. So I can sketch this like I normally would. The y-intercept is 3. 1, 2, 3. My slope is -1, so it's down 1, right 1, down 1, right 1. I just keep going. Just want to be a little bit careful here. That's going to be a closed circle, and that's going to be a closed circle. All right, so I just have to fill that in right there. And the last one. So what I notice here, number 1, it's a square root graph. Number 2, it's been shifted right 3. Now, I'm not shifting it up or down at all, so hopefully you guys remember our base functions. And basically I'm taking this graph right here and I'm shifting it right 3. So this point here, which is the origin, goes right 3. So if you notice, that's going to hit right here. And then my pattern is over 1, up 1, over 4, up 2. Okay, over 1, up 1, over 4, 1, 2, 3, 4, up 2. And there's that third piece. Now, if you're questioning whether you did this correctly, you could take this point right here, which is 3, 0, and plug it in. Okay, if I put a 3 in here, I get 3 minus 3, that's 0. Square root of 0 is 0, so that one works. This one here has coordinates 1, 2, 3, 4, 1. So I could put a 4 in here. 4 minus 3 is 1. Square root of 1 is 1, and that also works. And then the third one over here, it's 3, 4, 5, 6, 7, 2. So if I put a 7 in here, I get 7 minus 3 is 4. Square root of 4 is 2, and that checks. So I'm pretty confident I did that part correctly. Our final example, h of x, is 4x plus 8 when x is less than or equal to -2. X squared minus 2x minus 8 when -2 is less than x is less than or equal to 4. And absolute value, x minus 6 plus 3 when x is greater than 4. So first thing we're going to do is evaluate these algebraically. H of -6, again, what you have to do is figure out where is -6 in these intervals. Well, -6 is less than or equal to -2, so it's here, which means I'm using that piece. All right, so it's going to be 4 times -6 plus 8. -24 plus 8, what is that, -16? Okay, so my next one now is h of -1. Where is -1? -1 is not less than or equal to -2. -1 is between these, so I'm going to use this. All right, so -1 squared minus 2 times -1 minus 8. So that's going to give me 1 plus 2, right? Watch your negatives, minus 8. 3 minus 8, that's going to be -5. And my last one, h of 10. 10 is not less than or equal to -2. It's not between -2 and 4. It's here. It's greater than 4. So since 10 is greater than 4, I'm going to be plugging into that piece. So I get the absolute value, 10 minus 6 plus 3. That's going to be 4 plus 3, and obviously that's going to give me 7. All right, let's sketch this graph. So again, you don't have to do this. I kind of do it as a visual. I know the parts are going to change at -2, and I know the parts are going to change at 4. So if you want to kind of highlight, hopefully you've got a highlighter that's a little thinner than this one, but at -2, they'll change, and at 4, they're going to change. All right, color code here. Let's do this one in blue. Notice again, this is just linear. Slope is 4, y-intercept is 8. But we got to be careful because the y-intercept is not going to be graphed. Notice this is not in that interval. I'm only going to sketch it in this region here. So if you want to work backwards, feel free to do that. My y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8, but that's not going to be on the graph. Slope of 4. So if I want to go backwards, it's down 4, 1, 2, 3, 4, over 1. Down 4, 1, 2, 3, 4, over 1. This right here is the first point you're going to see on the line as you go towards negative infinity. All right? And then let's just continue that slope. Down 4, 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1. And then you can sketch that in. And again, like I said before, if you're questioning whether you did this correctly, you can take this coordinate here, which is negative 2, 0, plug in a negative 2 here. 4 times negative 2 is negative 8. Negative 8 plus 8 is 0, and that checks. All right, I'm not going to take the time to check the other two. You can do that on your own if you're not quite sure. So this next part is a little bit more challenging because this is an equation of a parabola, right? It's a quadratic, but I don't know what that looks like off the top of my head. I can't see the transformations. It's not in vertex form. So here is a good example of one you might want to create an XY chart for. All right, and what I'm going to do is I'm going to start my chart at negative 2 and go up to positive 4. All right, even though that's an open circle, I still need to know where that goes to plot that open circle, if you will. So I've got negative 2, negative 1, 0, 1, 2, 3, 4. Now I'm simply going to go through quickly and plug into this. Again, I'm not going to show all the work. This would most likely be calculator active, but not necessarily. It's not too hard. If I plug in a negative 2, I get 0. If I plug in a negative 1, I get negative 5. If I plug in a 0, I get negative 8. If I plug in a 1, I get negative 9. And that's the vertex, so then it changes directions, negative 8, negative 5, and 0. So now what I'm going to do is I'm going to take these coordinates here, and I'm going to plot them in this region here. All right, negative 2, 0. Now remember, it would be an open circle. However, negative 2, 0 is the same as this coordinate, and we do not put open circles on top of closed circles. So I know it just goes to that point. Negative 1, negative 5, 0, negative 8, 1, negative 9, 2, negative 8, 3, negative 5, and this one would be a closed circle right here. And that's 4, 0. All right, so here's this piece. Notice that the two have a point in common. And now my last piece. Absolute value. It's been shifted right 6, up 3. Remember, that's going to be the vertex. There's no reflection over the x, so it's just going to be a v. That's been shifted right 6. So 1, 2, 3, 4, 5, 6, up 3, 1, 2, 3. That's going to be the vertex right there. Let's see, 1, 2, 3, 4, 5, 6, 1, 2, right there. Now going towards positive infinity, pretty straightforward. You can just sketch this piece in. But here's where we have to be very careful. And I'm actually going to erase some of my highlighter because this isn't going to show up. But notice this is an open circle. And the other piece of this is going to go here. And it's got to stop. Now, this point and that point, they're not common. It's not the same point. So this one is closed, but this one has to be open. So when you go to sketch this in, this has to be an open circle. All right, so let me just erase that part. And this has to be an open circle. And again, if you're not quite sure if you did that correctly, you could take this coordinate, plug it in here, the x value, and see if it works out, which it does. You could check it with all of these. Again, I'm not going to take the time to do that because I know that is the correct answer. Okay, so there's a few examples on piecewise functions. We're going to spend a few more days writing equations of piecewise functions, evaluating them. But as usual, if you guys have any questions whatsoever, please don't hesitate to reach out or ask in class. Hope you guys are doing well, and we'll see you soon.